Hey guys, how are you doing? And welcome back to another episode of Meccano Creations. So today I want to finally showcase something which I've been desiring to build for a long time, for a lot of years. So this is my Arduino-based transmitter, and this is the receiver box for it. And in this video I'm going to demonstrate quickly how you can use this transmitter and receiver to control your Meccano models. Okay, so this is just the first version. I'm quite happy with it. It works. It does what I wanted to do, and yeah, this is the first version. Obviously there will be more improvements on this receiver box as well as the transmitter, but I will get to it a few minutes later. Okay, so let's just demonstrate what I've done here. Now those who are following my Facebook page, they would remember this time-lapse slider which I built quite some time ago, but I haven't been able to put a video across yet. But I would use this one to demonstrate what I've done with the transmitter and the receiver today. Okay, and I have a Zephyr Mechanix motor. This is a geared motor, plenty of torque, so this is a nice one. We are going to control this one as well. And I have a MG995 Tower Pro servo motor. Okay, so this receiver box will be able to control all of this outputs through this transmitter. So it has two cables which will be linked to two motors, and you have this pin headers over here which you can use to plug in your servo, and you can control all these three outputs. Okay, all these three devices. Now let me first go one by one. Let's talk a bit about the transmitter first and then the receiver. Now this transmitter is using obviously an Arduino Nano. It is using also an nRF24 module with the antenna and the power amplifier built in. This is the box which I made out of PVC pipes. So you can use PVC pipes, cut it, flatten it out using a heat gun, and use it for your projects. Okay, it's a very good material for your DIY projects. It is nice and durable. And I have this battery box behind it. It has 6 AA batteries, so it's 9-volt input, which is fed into a voltage regulator within this box, and that 5 volts is used to power your Arduino and all of this inputs that you see. Now I put a bit of a branding, colored the box obviously to make it more pretty for my videos, and it has got 2 potentiometers, 4 switch buttons, and 2 joysticks. Okay, so I will be using this for most of my future projects, which you can view on my channel. So please do share and subscribe to get more updates. And right now for this receiver, the inputs which will be applicable are these two potentiometers, which will be used to tune the angle of the servo. For example, if you are using this for your steering for your RC car, so you can actually, without reprogramming your receiver, you can actually control what will be the minimum angle and the maximum angle through this potentiometer. So this one controls your minimum and this one controls your maximum. So that gives you an opportunity to a mechanism to quickly tune your steering mechanism for your RC car. Now these 4 push buttons, right now they are of no use. I'm not using this for any of my outputs. So this is right now for future modules. Maybe I will be using it for other projects. This one can control both the motors, both the DC motors, so y-axis and x-axis. So you can control forward, reverse for each of the 2 motors. And the last one is the servo. So you can only control it through y-axis. And also I forgot to mention, this one you can control the speed as well, so this is PWM enabled. Okay, and all of this programming is mainly done within the receiver box. So the transmitter is only supposed to transmit the inputs, which will be captured by this box. It also contains an Arduino Nano and in RF24, same mechanism, and all the programming, all the logic which you want to control. So for an RC car, you have a different set of codes. If you want to control a crane which has more motors, you can obviously build your receiver module which will have more outputs and control them with the same transmitter box. So you need not reprogram any of your things here. All of the code, all of the logic is built in the Nano for the receiver box. Now obviously, again, this casing is again built using your PVC pipes. I flatten it out, it's nice. And I also have a bit of a cutout where you can actually plug in your Arduino cable like so. You first have to disable your whatever battery connection you have, switch it off, otherwise it might destroy your Nano. So what I would do is, if I have the battery connected to this cable, I would just disconnect it and then go about programming my receiver. Okay, so this is an easy way. You just plug it in your USB on your laptop and you are connected. So all of the inputs that the receiver is receiving from this transmitter, you can easily view it in your serial monitor, and yeah, whatever logic you want to change, you can change. Now this one is rated for 7 to 12 volts. Okay, so don't put anything above 12 volts, otherwise it might destroy the motor driver module. I'm using an LM298 for now, which obviously I know it's not the most efficient, but future projects which I build will use separate motor drivers, more efficient motor driver circuits. So this is your on-off. Plug it in your 7 to 12 volts. Right now I'm using rechargeable batteries here, so each of them are 1.2 volts, so it's around 7.2, I would guess. 12, yeah, 7.2 volts in total right now, which will be used to power this motor, this servo, and this time-lapse slider. So enough talking, let me demonstrate how it works. So I'm going to first connect my battery here. Battery connected, all of through GST connectors. I will plug in one of the motor outputs to this cable. I will connect the servo and make sure your pin is signal pin VCC for the power and the ground. So my box has notation, so ground is the first one here, VCC is the middle one, signal is the last one. Okay, so I will plug it in that order. So connect it here, and there you go, all of your motors and servo connected. I just need to connect the last one. Let me rearrange. So this is connected, and when I switch it on, you would see, yeah, there's a bright glow. So it's switched on right now. Now what I'm going to demonstrate is the speed control of this time-lapse slider. I think I should get a better angle so that you can see how the time-lapse slider moves and how you can control the speed. Obviously you can see the servo functioning through this top-down shot, but I think I need a better angle to demonstrate the slider. So here you go, guys. Hopefully this one is better. So I will just switch on my transmitter now. Transmitter is switched on. Now what you can do is, the way to trim your servo is, if you can control or tune your angle. So I'm holding up the servo to the max position, and the minimum angle you can control with this pot, right? So you can control actually how much the servo arm will be moving when it's at the max position. Okay, so in this way you can tune your steering, and when you control your servo, let me show you. Let me give you a better angle here. Yeah. Okay, so you are controlling your servo right here, and then moving on to the speed control. So you see you're controlling your speed of the slider. This is stop, this is okay, this is crawling, almost crawling. Okay, and you need a bit of a minimum voltage to get the motor moving. The reverse. And now the other one. So there you go. This is how you can control all your 3 inputs, servo and the motors, and you can control 2 motors simultaneously. So there you go. And also this is meant for RC cars, right? So there might be scenarios where your transmitter and receiver might lose the communication, and there should be a mechanism where you will switch off all your outputs if there's a gap in the communication. So right now what I've done, there's a bit of code in this receiver board where if it's not getting any signal for 3 seconds, then it will automatically shut down everything which is doing. Okay, so your servo will be back to your 0 position, motors will stop. So let me demonstrate that part to you. So what I will do is I will start off my motors, push it to the max position so everything is moving, and then shut down my transmitter so it doesn't receive any signal. So ideally what should happen after 3 seconds, the motors will stop. So let me pull it to, okay, so I'm just getting it to the right position. Now what I will do is I will push it to the max of the y-axis and then shut down my transmitter. Let's see. 1, 2, 3. Started, and I'm going to shut down. Done. So automatically your receiver has shut down everything what is doing, and once I switch it on again, it will reset itself Okay, servo goes back to where it's supposed to be, and then again you can control what you're doing. So a handy feature, if you think about it, if you're controlling your RC car outdoors, there might be walls, there might be obstructions which might interfere with your Arduinos and the nRF24s, and in that scenario your car should not go and crash to a wall perhaps. So a bit of a safety mechanism, I think it can be improved further, but yeah, it's working for now. So what's the next step here? The next step, now my review, let me switch it off, let me disconnect. So what are my thoughts on this and what am I going to do next? So many wires. Okay, what am I going to do next? Obviously this box, it's around 10 centimeters, 9 centimeters by 4 centimeters. It's not bulky, but it occupies a lot of space. Okay, so it's nice for if you're building big cranes, but for RC motors which operate at, let's say, 3 to 5 volts, you would ideally build a smaller chassis, so this might look big on that chassis. So I want to get rid of this box. This is okay, this was the first version, but let me show you what's inside so you can get the picture. So you can easily remove these two nuts, open up the case, and this is the box. Okay, so a lot of things there. You have your LM298 motor controller, you have your Arduino, you have couple of 5 volt voltage regulator. Now, why important point, if anybody is working on this or plans to use Arduinos for RC control, you want to keep your 5 volts regulators separate, in the sense one 5 volt regulator should power your Arduino, the other one should power your servo. You should be controlling your servo right from the 5 volt output of your Arduino. That's a recipe for disaster. Neither should your nRF24 connect directly to your 3.3 or 5 volt output of your Arduino. So what I've done is I have a dedicated 5 volt regulator which feeds from the same 7 to 12 volt supply. This 5 volt regulator will supply your Arduino, your NRF, and the other one is only meant for your servo control. So that way you create a bit of an isolation. And obviously your main power bank should be powerful enough so that you can supply the required current. So over here I'm using your Duracell 1300 mAh batteries, which is quite powerful, and you can go higher. There's a version where it's 2300 mAh, so that's even more powerful. And obviously this is a 6 cell case. I have battery cases which are 8 cells, so that's 9.6 volts, and that will allow you to control an output of, let's say, 7 to 9 volts. Okay, you can obviously use a buck converter instead of a linear regulator such as this. That will be more efficient. Now what I plan to do next is, obviously, as I said, make it smaller. So I think what I will do in the next version is I will use something called, let me bring out my box here. I have a big box of controllers and I want to use this DIYRC, a small motor driver which can control two motor outputs, and you can use PWM over there as well. So if you just compare the size of what's the LM298, big, chunky, inefficient, with the modern ones, DRV, which is very small, okay, compared to that. So I can use multiple within the same space and have it control not just 2, maybe 4, 6, whatever. within the same space, and that will make it very handy. So that's number one. I need to try out this modules a bit before I can create a solution. So that's number one. Anything else? I think the range is pretty good with this one. I think it can work 80 to 100 meters easy, and I've not tested beyond that, but I can think it can do more. I have put a capacitor with this in RF24 to make the voltage even more stable. Some of the best practices that I've got from the internet, so I've tried to apply it as much as possible, but I can think there's definitely room for improvement. So yeah, I mean, that's basically it. And also right now 3 outputs, right? But my Arduino has plenty of free analog pins. Okay, so I want to have a mechanism where might be the board might be bigger or something, but all of these outputs, all the free pins will be extended so that you can control different outputs, multiple outputs through those available pins. So that just gives it extension to, you can extend it to something you built recently. Okay. So that's basically it. I want to play with it for now for a few days. I want to build an RC car and see how it actually works, but it looks promising. It works fine. I haven't encountered any abnormalities within the communication. It's pretty stable communication, really. So good to be used for my future Meccano models. Now, if you guys have any constructive suggestions, or if you want some guidance, obviously you can comment on this video, and I will be posting a small video on my Facebook page, Science Meccano page. If you want to join there, follow there. So yeah, feel free to comment, and if you want to build your own, definitely go for it. You just need a good power supply, right? Your standard 9-volt cells won't do. You use a good power supply, okay, which can supply plenty of current. And yeah, thanks guys, see you in the next video. Bye.